Hi guys, this is Achut. Welcome back to the channel. So we'll be solving today's LeetCode question, which is find the bottom left tree value. So by the title itself suggests that we need to find the bottom left tree value. Suppose let's say we are given a binary tree. Binary tree in the sense there will be a root node and then there will be a left node and then there will be a right node. So in this particular example, if you see like this is the first root node, and then this is the left child, and then this is the right child. So out of all these tree nodes which are present in the binary tree, we need to return this tree node. Why? Because this is the bottom left tree node which is present in this particular binary tree. So we are returning here one. If we come to the second example, here it states that we are given 1 and then 2 and then 3 and then 4, 5, 6 and then 7. So in this particular example, what is the leftmost value which is present at the bottom? If you see here, this is the leftmost tree node which is present at the bottom of the binary tree. So we need to return this particular value. So how can we solve this? Suppose let's say at the starting we'll visit this one. Okay. And then again we'll call the left child. Okay. And then as we call left child, this will again call the left child. Okay. And then we'll store answer equal to 2. Why? Here we can say uh, if we compare if we compare the nodes which is present at y and then which is present at the 2, then we can say that height of this particular node is always greater than this particular node. So whenever height at here becomes the maximum height which we have already stored at the global level, then we can say answer becomes 2. And when we come here in the fourth node, then we can say answer equal to 4. Answer equal to 4. Why? Because the height of this particular tree node is greater than this particular tree node. Like the global. The global will be the global height is going to be 2 as of now. Why? Because here it is 0, here it is 1, here it is 2. And again we'll call the right tree. So at this particular point, the height is this is the maximum height, and then this is the height. Height at this particular point is going to be 1. As 1 is always less than 2, we cannot add it to the answer. Answer cannot be 3. So we'll move again here. We'll call the left child, and then again we'll see the left child. At this particular point, height is going to be 2, and then 2 is not greater than 2. So we'll not add it into the answer. So again we'll move to the left child, and then at this particular point height is going to be 3, and then maximum height is going was 3. So as 3 is greater than 2, we are going to say answer is going to be 7. And then again when we come back here, the height is going to be 2. The maximum height has already become 3 at this particular point. If 3 is greater than the maximum height, then we are going to assign maximum height to whatever the height which we had got here. So at this particular point, the maximum height is 3. So here at this point, we are not going to assign answer equal to 6. So why are we traversing the left from the left, not from the right? Suppose let's say if we start from right, let's say we have here one more node called 8. And then let's say we'll start from right. Okay. and then the maximum height is going to be 0 at the starting, and then height at this particular point is going to be 0, and then we'll call the right child. At this particular point, height is going to be height is going to be 1, and then as 1 is greater than 0, then we can assign answer equal to 3, and then the maximum height is going to be 1, and then again we'll call the right child, and then height becomes 2, and then answer is going to be 6. Why? Because 2 is greater than maximum height. So maximum height is going to be 2 again. So now we'll move to the next step, and then height becomes 3, and then again we'll assign answer equal to 8. So at this particular point, answer becomes 8, and then the maximum height is going to be 3. And if we visit here, the height is going to be 2, and then again height is going to be 3. So whenever we visit the right in the first place, then we are going to assign the rightmost value. Suppose, let's say, if you want to visit the right at the first place, then we are going to replace this particular tree node with the left child, with the left bottommost child. So how can we do that? We can do by a, like, suppose height is greater than or equal to maximum height. If we use this particular condition, even though height of these tree nodes are same, as we are saying height is greater than or equal to maximum height, this node is going to replace this node. Or otherwise, we can use height is greater than maximum height by taking only left child at the starting and then right child in the next. So we are going to use this particular solution for this. So let's go through the code once. At the starting, the answer is going to be like a default value, and then we are going to call some recursive function, which is recursive find bottom left value, and it is going to take one root, and then it is going to have the answer variable where we'll store on answer, and then again we'll have the maximum height, which stores the maximum height which we had visited till now. So at the starting, we need to write the base condition. That is, when the root doesn't exist, then we need to return it. And then let's say we had got the maximum height now, and the height which is already been present is less than this particular height. Then we are going to say the maximum height becomes the height which is present right now, and then answer is going to be root value. Why? Because this is the particular height where it is a bottommost. And then again, one more thing we need to take care is we are visiting the left tree. So we are using height is greater than maximum height. Suppose, let's say, we are visiting the right, then we are going to use height is greater than or equal to maximum height. So you can see the examples by using those conditions, and then figure out like why we are using greater than or equal to maximum height, and then height is greater than maximum height. Left tree node, and then again we'll call the right tree node. From this particular cases, we'll get to know the answer. So we'll be returning the answer. And if we see the time and space complexity, the space complexity is going to be big O of h, which will be the height of the tree. Suppose, let's say, I'm going like this, and then again like this, and then again like this. So this particular height is going to be the space complexity. Why? Because We'll store this particular node, we'll store this particular node, and then we'll store this particular node, and then we'll store this particular node in the stack, because we are calling the recursive function. In the stack, the recursive function is going to be stacked with the values which are present at that particular function. So it is going to be big of it. And then what about the time complexity? As we are saying, we are visiting every node which is present in the tree. We'll visit this one, we'll visit this one, and then we'll visit all the nodes which are present. We can say that the time complexity is going to be big of number of nodes which is present. Yeah, that's all for this video. Thanks for watching the video.